Hello guys, welcome to the new video again. In this video, we are going to discuss some questions, new topic, which is combinations, right? So let's start, right? So we have discussed permutations in all our previous lectures. In this lecture, we will be discussing combinations. So combination is our new topic. There are two types of here. Uh, Combinations are like uh, arrangements in which we can say arrangement in which order does not matter. All right. And next is some keywords regarding to combinations like select, right? Selection, set, subset, right? These are keywords to hint you that it is a combination thing. Team and committee, and we can say collect, and so on, right? These are some. One second, let's change the color of this to which color? Is it green? No, this would be great. This would be not. This is great, right? So there are three type of problems and combinations. First is combinations with no repetition, right? Second is combinations with limited repetition, right? And third is combinations with unlimited repetition, like permutations. These are three types also, right? So let's see some examples one by one. Right. Examples are first topic here in examples is first type problem, combinations with no repetition, right? The question is make committee of 3% out of 15 people, right? Make committee of 5 people out of 15 people. All right. So what is here is or combination? It will what we can we say? It is a combination thing because uh, select or committee selection is here. Right? We have to select, not arrange. Right? How many ways we can select 5 people from 15 people? All right, this is a problem. So in this P1, let's say P2 and P3 are 3 people. It is equivalent to here P2, P1, P3 and equivalent to P3, P1, P2, and it is equivalent to P3, P2, P1 also, and P2, P3, P1 also. Alright, P1, P3, P2. So these are all equivalent because order does not matter. Order does not matter. These all people are same people. This is only one way, alright, of selecting them. So here there is something changing here. How many? 1, 2, 3, 4, 5, 6. 6, right? 6, 3 into 2, right? Means 3 factorial always. 3 factorial is uh, are equivalent, alright? So if we are selecting, if we are selecting our pupil from n, where n is greater than or equal to r, so in this r factorial uh, combinations will be equivalent to each other. Alright. So what we can do here is, uh, let's say there are n people, so we can arrange them in n factorial ways. Arrangement would be like n minus. We are going to select r people. Alright. So NPR formula is n minus r factorial. Alright. This is the NPR permutation. But we have to what we can we have the r factorial uh, r factorial there is set of r factorial people are equivalent to each other. All right, so we have to divide r factorial by r factorial because how can I explain here is we have to divide r factorial because there are p1 p2 and p2 p1 equivalent these two people, all right, and p4 p5 and p5 p4 they also equivalent. So we have to and p1 p3 p3 p1 these are equivalent to 2 factorial. We have to select two people from 5. So these are all equivalent sets, all right, and p3 p4 is equivalent to p4 p3. So for all two sets or combinations, we have to divide with r factorial only. Hope you understand here, right? So next question for that was 15 people select 3. Select 3 is it? Select 3%. So it would be like 15C3. C is 15 factorial upon 15. What is this? Right. Wow. Right. 15 minus 3 factorial is there, and 3 factorial divided by 3 factorial. All right. Next is note here. Note here, people are distinct always. All right. So in this question, pupil, or we can person, or we can say human, are always distinct. We can say unique, not identical. All right. So by default it distinct till it is specifically mentioned. All right. 2% A and B must be selected. So in the this that questions only 15 3 question. Thus modification is two pupil A and B, let's say, must always selected. So what will be the question? A and B are selected. Now how many people we have to select? From how many? From 13 we have to select one only. This is the question. Uh, Alright. So some general formula here is from n select R, but but X always select, X number always select. So it would be like n minus X C R minus X, like that. And it can be modified as X never selected. It will be n minus X C R, right? Next question here is from 15 make committee of 5. Committee of 5. So in which A and B always selected but C never selected. A, B always, but C never. Alright. What will we do is always selected formula is what? 15 minus 2 C 5 minus 2. Never selected formula is 1 minus 1. But wait a minute. Right. Right. So C never n minus x on the latest formula basis. Right. Next question is set and subset. Next type of question. Set and subset. How many subset of a set of 3 uh, right, set and subset, right? So what is how many subset of a set of 3? What is the question? 3 element, but element is this 3 element. There are typo in the question. So question is here, uh, how many subsets of a set of 3 elements, of a set of 3 elements? So how can we do this? Let's say 1 2 and 3 are the elements. How many set subsets are possible? So subset would be like uh, from 3 we can select 0, plus from 3 we can select 1, from 3 we can select 2 elements, plus 3 we can select 3 elements. So it is 1 plus 3 upon 2, 1 plus 3 to 3 upon 2, 1 plus 1 only. 3, 3, 3, 6, 7, 8. 8 is the answer. Is it? Yeah. And this is the generalization for this. It will like 2 to the power 3 elements is there, and so 3 2 to the power 3 is 8, right? This 3 is the answer, right? This is generalization for the summation of r is equal to 0 to n, ncr is equal to 2 to the power n. This is the answer, general formula, right? Or we can say like that there were 3 elements, all right, 1, 2 and 3, and we can say like present, absent. There's two options here: present, absent, present, absent. All element has two options. It will be 2 into 2 into 2. It will be 8. Right? Yeah. So order doesn't matter. It is not matter here. We are playing box method here. Box method. And question will be like, question is here is how many subset is exactly 3 elements of set 10 elements. So subsets of 3 elements from the set of 10 elements. How many 3 subsets are possible here? Alright. So the general approach would be like there are 10 elements, 1, 2, 3, dot, 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 10. We have to select 3 out of them. Right? We have to select 3 out of them only. So it would be like 10, 3 is the answer. We have to select 3, any 3. So yeah, this is the answer only. Alright. And little bit modification in this question. At most 3 elements. It will be like at 0 plus 1 of, this is not like that. We can select 0, we can select 1, we can select 2, or we can select at most 3. This is the answer. Alright. Our next modification in the question is at least 2 elements. Alright. What is this will like? Solution for it is at least 2 elements. At least 2 elements means what? Uh, Total minus uh, exactly 0 and minus exactly 1. It will be like 2 to the power 10 minus exactly 0 is 10c 0 minus 10c 1. This is the answer. Right. Second method will be like 10c2, 10c3, 10c4, and so on, 10c10. This is our answer. Right. And little bit modification in this also here is always include 2 and 5. Right. This is the always include 2 and 5. So it will be like in that question only. Is it? In this question. How many subsets are possible? This is saying how many subsets are possible. It will be like 1, 2, 3, 4, 10, and everyone has two options, present, absent. It has only one option, present. So it will be like 2 to the power 18 answer. Different types. And here is 2 and 5 never included. It will be like 8c0 plus 8c1 plus 8c, 2 to the power 8 also answer, right? Next modification here is 2 and 5 exclude and include 7. So exclude means 8 is there, include 7. It will be like 7's 7 are there. So 7 is 1 to the 2 to the power 7 is the answer. Select element from 2 more sets. Right. So this is the questions type. Next here is select elements from 2 or more sets. Right. So question here is there are 6 boys and 5 girls. Alright. So how many ways we can make a team of 5 people, 5 people, 5 members, in which 3 boys, 2 girls. So there are let's say 6 boys and 5 girls. Alright, we have to select 3 boys from them, so 6c3, and 2 girls from them, and we can, and now we can multiply them. This is the answer. But little modification, at least 3 boys always in team. At least 3 boys. It will be like 3 boys, okay, 4 boys or 5 boys always, right? So it will be like when we are selecting 3 boys, it will be 6c3 into 5c2 plus 6c4 into 5c1 plus 6c5 into 5c0. This is the answer. And next is at least 1 boy. So at least 1 boy will be like no boy. It will be like total minus no boy. Right? Total is what? We have how many? 6, 11. 11 people, and we have to select 5 of them. Right? This is the total minus no boy team. No boys like 5C5 all girls into 6C0, it will 1 comes down to 1, and it will be like 11C5 minus 5C5 is answer. Alright. Question next year is 6 boys and 5 girls. Make a team of 5 members. A team of 5 members. Right? As 3 boys and 2 girls, where boy A is always selected. 5 members and 3 boys, 2 girls always, and boy A is always selected. So boy A is always selected, so we have to select only 2 boys from 5. 5C2 into, we have to select 2 girls from 5C2. This is the answer. Right. Next is boy A and girl B should not be included together. Right. Boy A and girl B, they have some files should not be included together. So when boy A is selected, it will be like 5C2 into 5C2, right? Is it 5C2? 4C2. Alright, 6 boys are there. Alright, 5C2. 5C2. 6 boys are there. Alright, this is 1 plus when uh, girl B is not selected, right? Wait a minute. We have to minus total when both A and B are selected. So this will be complicated, right? So it will be like total minus when A and B are both are selected, right? So it could be 6C3 into 4C1 also. Not selected, plus both are not selected. So 5C2 into 5C2. Both are not selected. So what the 5C3 into 4C2. Both are not selected. Method 2, complementary method. Complementary method is like total minus this. So 11C3 minus A and B both are selected. 5C2 into 4C1. No, this was the total was like this. 5C2 minus 5C2 maybe 4C1. This is the answer. Right. Next topic is playing cards. Right. Next type of combinations are playing cards are here. Now we will discuss playing cards. In playing cards, we have 52 cards in a deck. Right. So let's see some example here. From 52 cards, so how number of ways uh, a row, two kings plus draw. Number of ways from 52 cards. Number of ways draw two kings if five cards are drawn. This is the question. So what we can do here is uh, we are not taking probability here. This is not a probability question. We have to how many ways we can draw. So we have 52 cards in which we have 4 kings and rest of 48. In these 48s we have to select only 3. So it will be like 48C3 and from 4 we have to select 4C2. Answer would be 4C2 into 48C3 is the answer. Right. Next would be like 2 king and 2 queens. Uh, 2 kings and 2 queens. How many ways? So we have 52 cards. Uh, 4 kings, 4 queens, and rest is 44. Right. And from this, we have to select 2 kings, we have to select 2 queens, and we have to select one only. So this is the way. Next question is here. Next question is 50 questions divided into two groups. Group 1 is has 50 questions are there. Group 1 has 25 questions and group 2 has 25 questions also. So 10 questions selected such as at least 6 from right. So 10 questions selected, right, in which at least at least 6 from G1 and at most 3 from G2, right. So what we are doing here is 10 questions are there, right? 52. So we have group 1, right? Group 2, we have 25 here, 25 here. We have to select 10 questions only. So we are going to discuss that at least 6 from uh, this, right? So when we are we can take 6, 25, C6, right? So when we are taking 6 here, so from this group we have to take 4, right? So but we cannot take 4 from here because uh, at most we can take here from here is 3, right? So this is not possible. But when we have to take 25, 6, 7, right, we can take 3 from them. 25, C3, alright? One case, alright? Plus, when we take 8 from here, 25, C8, then we have to take 2 from them, right? Plus 25, C9 into 25, C1, plus 25, C10 into 25 C0. This is the answer. So I hope you understand how it has been done. This is a very important question. All right. Next is here question. Let's say question is here. Set is 1, 2, 3 and 10. This set is given. Alright. Now question for this set, three distinct and arrange them in ascending order. Huh? Select three numbers and arrange them in descending order. So how many ways we can select three of them? Distant 10C3. But how many ways we can arrange them separately? Only one way. So 10C3 is the answer. But but when we are doing here, but if we modify this question here, say select three and arrange in different ways. So it will be 10C3 selecting and 3 factorial arranging, right? This would be the basic multiplication rule here, right? So next question is five zeros we have, five zeros, and 15 ones we have, 15 ones, right? How many 20-bit binary number where even every zero is followed by at least one word? So 20-bit binary number where every zero is followed by at least one one. This is a very different question altogether. So we have five zeros here. 1, 2, 3, 4, 5. So and we can put one ones all here. These five ones are distributed, but now we have places to put them. 1, 2, 3, 4, 5, and 6 places to put rest of 10. So 10C6, we can select 6 after, we can say, yeah, 10C6 is there. Is it not like that? 0, 1, 0, 1, 0, 1, 0, 1. At least one word. It's going to followed by 2 also. Five is here, and one is 10 here. So what we are doing here is 10. Is this 10 factorial of 1, 4 factorial, 6, so 24 factorial. Okay, this is not correct. So in this question we are doing like we can do this like that. We can make bundles 0, 1, 0, 1, 0, 1, 0, 1, 1, 2, 3, 4, and 5. What is the with the network? What's wrong? Huh? Connecting, not connecting. Okay. Connect. disconnected. Alright guys, we can make bundles here. No, is it connected back? 40 minutes. Right, where was our question? What the hell? Right, this was the question. Right, so we can make bundles here like 0 1 0 1 0 1 0 1 and 0 1, right? 1 2 3 4 5, right? And now we have ones 1 2 3 4 5 6 7 10 ones, right? Present. So they have how many positions left? Total of one. Total numbers are 50, right? How many ways we can arrange them? Is it like that? Is it like that? Yeah, it is like permutation. Permutation with limited repetition. It will be like how many are there? 15 factorial, 10 factorial, and 5 factorial. This is the answer. Right. What was the wrong with that process? I am thinking. We have zeros for 0, 0, 0, 0, 0, like that. All right. And we one like that. How many places we have required? 1, 2, 3, 4, 5, and 6. These are 6 places are there. But we have 10. 10 ones, right? What can we do? Can we make say 10 people on 6 chairs? No. So this is not the way. So yeah, this was not right way. So we can't do this. All right. Thank you. Can we check on Chat GPT this question? Yeah. So 5. There are 5 zeros and 15 ones. Five zeros, 15 ones. How many 20-bit binary number where every zero is followed by at least one are possible? Is it like that? Possible. Right. Let us ask this question. Wait a minute. First, for the first 0, it can be followed by any number of ones. So, for 15, so there are 15 possibilities. Alright. For second 0, it can be followed by any number of ones from 1 to 15. So, there are 15 possibilities. Is it? Is it that simple? No. Are you fooling me? No, 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 no. This is not the case. No. This is not the case. This is not how you do this. Oh God. इतना रॉन्ग कैसे हो सकता है भाई? That famous Hrithik Roshan dialogue. Right. Can we go for Gemini? Right. Is this doing good thing? Ooh, this is something nice about it. We have 5 zeros to place 20-bit number. Every 0 must be followed by at least 1. 1. Alright. So we can think of 0 1 pair as single unit and we have 15 ones. Alright. Is it like that? Wow. 2 units and 20 units, 5 zeros and 15 unit pairs of the 20-bit number. Alright. Total of ways to arrange these units is given by the original binomial coefficient. 10 factorial, is it? 15 or 10? 20C5 is like that. Oh. Not like that. It's like factorial of 15 divided by factorial of 10 and factorial of into factorial of 5 like that, and I can says right answer G. Yeah, he is very wrong, guys. This is not giving correct answers. This is not combination, this is permutation with limited repetition question. Right. Thank you so much for watching the video. Hope you understand the last question was very important here. Thank you so much.